Hey, so we're going to show you a tutorial of our project here. The project is titled OpenCV Object Detection Without TensorFlow on the Raspberry Pi. Authors for it are Daniel Karasik, which is myself, the guy that's doing this video, Linda Vu, and Rachel Wendell. We're all grad students at Kennesaw State University. This README, as well as all the code and everything, is up on Github. The repository is under the account Real Hullabaloo, REALHULUBULU, and it's the OpenCV Object Detection RPI repository. It's pretty easy to find. So we're just going to do a little demonstration to show how this actually works. We're using Thani as an IDE here. So it's clicking play, running the script. So the first thing it's doing is basically getting all the files together, but it's going to be running a calibration. That's me on the screen. So what it did is it took a picture to use as calibration, as basically the object is going to be detecting. Right now it's prompting, for what object it actually took a picture of. If we put in some erroneous input here, something that's wrong, it'll prompt me to put in something right. So we have this error handling for everything. I'm just going to input the correct things. We have person for object. Number is 1. There's one person in the image. And you can calibrate against multiple objects. In this case, we're just going to do 1. So then we're going to hit no. Next, it's going to be running the calibration here. What's cool about this is when it runs it, it actually tells you the time it takes to do this. Here, the time was 0.0068 seconds. It's very quick. What this does is this will knock down the threshold to a certain amount to make sure we can detect all objects. Right now, our object detection threshold is anything above 58% will get detected. That's how this works. So that being said, we're going to use that threshold and we're going to move forward with detecting. So now it's taking a picture of me. Give it a second here. So it says in this first iteration of running the program, it says it detected the person, which was me, with a 95% rating as far as there being a person there. It also tells you the time to detect. I'll tell you after this next shot. Yeah, and the time to detect for that first one was 0.0064 seconds. For the second iteration, it was 0.00629, so 63. So we're going to stop this real quick. And then as far as the files this creates, it creates some data files I do want to take a look at. So off the bat, it makes a calibration file. The image it was calibrating against was this one, to give you guys a flash of the past. And then as far as the actual data, this is the data that it saves for calibration. It's basically what was printed out to the console. And the other file it saves, it does the images, so it saves the raw image, but also saves the image with the detection box. I really just want to show you the image with the detection box. So this is the picture that I just took of myself. If you notice up here in the corner, it says person 0.946. It gives you like a rounded estimate, a rounded percentage as far as like what it detected. So that's really nice to have. And then the other thing to show you is the log file. So the log file here is a little different from the console. It gives you the threshold we're using at the very top, but this long array here are all the false positives and general objects it detected. So in this array is going to be the person object, me, that it detected, but that has a bunch of other false positives. And the way you read this is the third entry is the percentage, and if you look at some of these, it might be hard to see, but a lot of these percentages are around like 2, 3, 4%. So a lot of the false positives that this particular program reads out using mobile net and SSD for the model and detection are really low. I mean, they're like around less than 5%, so they're not really a worry. Then here it gives you the time to detect everything as was printed out in console, and it tells you what was detected in this first run, and then it gives you the second run here, same object dictionary, and then the same thing down here for time to detect, as well as the image and what was actually there. The other thing that it does do is this dictionary right here that gets saved to the log file is actually sent out as a notification to a device that's registered on the communication channel. The device in this case is my phone. So whenever this actually runs, any devices on the channel will actually get this this string right here. That's basically a dictionary that has the object that's detecting as well as the number. If it's below a certain threshold, in this case I think 5 is the threshold we set, it'll actually have an extra message here saying running low. So you know that that's generally running low where the object is depleting. Otherwise, if it's above 5, it just does the object being detected and the number that is there in the image, or that is detected. So thanks for your time, and this is a little rundown of our project. And once again, GitHub's up online, all the files are there.